We need to obtain the derivative of y with respect to x whenever y is given by this infinite series at a particular value of x, that is at x equals to pi over 4. So let's begin with our given infinite series. So here we have y equals to tangent of x whole raised to the power of tangent of x, which is again raised to the power of tangent of x, and this goes all the way up to infinity. So here the exponent or the power can be actually replaced with y. Now what we can do is we can take the natural log on both sides, and we will be doing the logarithmic differentiation. So this will be equals to natural log of tangent of x raised to the power of y. Now here we will use the property of logarithm that states that whenever we have log of a raised to the power of b, so this is simply equals to b times log of a. Right. So that means we now have log of y given by y times log of tangent of x. Now we'll take the derivative on both sides with respect to x. So we have ddx of log y. So this will be equals to ddx of y times log of tangent of x. We know that ddx of natural log of x, this is given by 1 over x. So ddx of log y will be 1 over y. Now since we have y here instead of an x, we'll multiply it to derivative of y with respect to x, which will be equals to the derivative with respect to x of y log of tangent of x, that will be dy over dx multiplied to log of tangent of x, plus y multiplied to derivative with respect to x of log of tangent of x. So let's further simplify. So we will now have 1 over y times dy over dx minus, so we'll transpose this first term from the right hand side to the left hand side. We have log of tangent of x. So this is multiplied to derivative of y with respect to x equals to y times, so here we have log of tangent of x, and that means we will have 1 over tangent of x. But since we have tangent of x instead of x, we'll multiply to derivative with respect to x of tangent of x. Fine. So this gives us 1 over y minus log of tangent of x, whole thing multiplied to derivative of y with respect to x equals to y times 1 over tangent of x multiplied to derivative of the tangent function is simply the secant squared x function. Fine. So this is now going to give us, what we'll do, we can isolate derivative of y with respect to x. This will be equals to, we have y, so here let's simplify secant squared x over tangent of x. So we tangent of 1 over tangent of x, that's actually the cotangent function. So we have cotangent of x multiplied to secant squared x. Now cotangent of x, that's cosine over sine multiplied to secant squared x, which is 1 over cosine squared x. So one cosine from the numerator and one from the denominator goes away. So this is going to leave us with y over sine x times cosine x. Now since we are going to divide it with this coefficient of dy over dx, so we have 1 divided by 1 over y minus log of tangent of x. What we can do is multiply both numerator and the denominator with y. So that means in the numerator we have y squared, and in the denominator we have sine x times cosine x. So this will get multiplied to 1 minus y times log of tangent of x. So we have obtained the value of derivative of y with respect to x. Now our task will be to obtain the value of this particular derivative at x equals to pi over 4. So that means let's find out the value of derivative of y with respect to x at x equals to pi over 4. So this will give us y squared divided by, so here we have sine x, so that will be sine pi over 4 multiplied to cosine x, which means we have cosine pi over 4. This will get multiplied to 1 minus y times, so we have log of tangent of pi over 4. Right. So let's use the values. So we have y squared divided by, so sine pi over 4, that's 1 over square root of 2, times cosine pi over 4, so that's 1 over square root of 2. So this will be now multiplied to 1 minus y times log of, so tangent of pi over 4, that's value is 1. Now we know that log of 1, that value is equals to 0. So this means we now have y squared divided by, so 1 over root 2 plus 1 over root 2, that's half. So that means this will go to the numerator to become 2y squared. And the denominator we have simply 1 minus y times 0. Because log of 1 is 0. And this is going to give us the value 2y squared. Now we'll also need to find out the value of y. So we will go to our first equation. So we had y given by tangent of x raised to the power of y. So that means we had, let's write it down. We had y equals to tangent of x raised to the power of y. So that means we have 2 times y squared, which will be 2 times tangent of x raised to the power of y whole raised to the power of 2, which is simply 2 times tangent of x whole raised to the power of 2y. We'll also have to substitute the value of tangent of x with x with pi over 4. So this will be raised to the power of 2y. Tangent of pi over 4, this value is 1. So with 2 times 1 multiplied raised to the power of 2y, which gives us the value 2. So that means the value of derivative of y with respect to x calculated at x equals to pi over 4, this value is equals to 2.